Hey everyone, I'm Anish Ramshekhar. I'm a software engineer at Microsoft. I'm a maintainer for the Secret Store CSI driver. Today I'll walk you through the Secret Store CSI driver and then introduce you to the new Secret Store Sync controller, a solution for managing secrets securely in Kubernetes. So background. Applications running on Kubernetes often need access to secrets like passwords, SSH keys, and tokens. However, managing these secrets securely can be challenging if these secrets are actually stored in external secret stores. And that is where projects like Secret Store CSI driver comes in. So the Secret Store CSI driver is a Kubernetes SIG Auth subproject that allows Kubernetes to mount multiple secrets, keys, and certs that's stored in enterprise-grade external secret store into pods as volumes. So once the volume is attached, the data in it is mounted into the container's temporary file system. And as a storage driver, it provides a familiar file system mount experience to compute workloads. It's also pluggable, which means anyone can develop a provider for the Secret Store CSI driver. And then it can load new values without any manual intervention. So whenever the secret gets rotated in the external secret store, you would automatically see an update in the mount path. And then in addition to the mount, we also optionally allow syncing the mounted content as Kubernetes secret. This is especially useful in scenarios where you have certs that's stored in external secret store, and then you want to sync them as Kubernetes secret and use that as TLS with your ingress controllers. And then finally, it supports both Linux and Windows workloads. So this is currently the list of supported providers that we have for the driver. We have about 6 of them. And what it means to be supported is you basically have your own provider set up, and then you have like test suite set up, and then we have like conformance tests in the driver, which if you pass, then you're considered a supported provider. So I talked about optionally syncing the mounted content as Kubernetes secret in the driver. And then once we had the feature, we got a lot of feedback from our users saying it was not an ideal experience. That's because you need to have the driver running on every single node. And then also the sync as Kubernetes secret was heavily tied to the mount, which was not an ideal experience. So we basically decoupled the controller from the driver, and that made that its own standalone project. So the sync controller is a new SIG Auth subproject. It decouples, it runs as a separate controller, and we have designed it in such a way that you can reuse the existing providers of the driver by packaging them as sidecars in the deployment. And then in terms of the features that the sync controller can offer, rather than running as a daemon set from the driver, now you basically just have a controller deployment packaged with sidecars. So you can run the controller in high privileged environments. Basically, you can run it in like a control plane node. Then in terms of offline support, what we mean by offline support is once you get the secrets from external secret store into your cluster, if there is a period of time where you have no connectivity to your external secret store, then your workloads will still continue to work because the secrets are stored in Kubernetes secret, and then you can just use it across your pods. And then reduce rate limits, because in this case, you're not talking to the external secret store every single time for every pod, but rather you're calling it once for one Kubernetes secret, and then probably after for rotation. And then in terms of seamless transition, we have designed it in such a way that we use the same custom resource that was supported in the CSI driver, and then we have a new custom resource called Secret Sync. So if you deploy these things together, you can easily transition from the driver to the new controller. This is a quick comparison of what the driver does and what the controller does. I think the points to note is, one is for a specific use case of you want to mount the secrets in the temporary file system, or if you have scenarios where you need to actually have this as a Kubernetes secret. In terms of providers, the same set of providers is supported for both because we've designed it in such a way. And then in rotation, for the controller, the rotation support is work in progress, but for the driver, it's been stable for a while now. And then in terms of how it's run, the driver and the providers need to run as daemon sets on every single node because it's a node local process. But in case of the controller, it's just a deployment with 2 replicas. And then in terms of the offline support and rate limiting, the controller can support those better just because it's sync once and then use across different pods rather than having the daemon set talk to the external secret store every single time. So in terms of what we are working on in terms of next steps, for the driver, we are moving towards a CSI native rotation model, which will help us reduce the RBAC permissions out of the box. And then we are also adding caching enhancements for the driver. And then we're going to come up with a deprecation plan for the sync feature in the driver once the controller is stable. And for the controller, we are working towards the beta milestone, and then we're also enabling rotation support, we're adding metrics, and then we're also doing load testing to ensure that it can handle high load. And then as I wrap up, here are a few ways that you can actually get involved in the Secret Store project. You can join the Slack channel on the Kubernetes Slack. That's one way. And then we also have bi-weekly community meetings on Thursdays at 9 a.m. PST. And here are some of the resources for everything that I presented. So we have the driver, the controller, and the provider documentation for the supported providers. Thank you.